All right, y'all, we're going to get started. Like I mentioned, it's a little different attendance today, so just mark yourself, mark yourself here. Just answer the stupid question. What file types do you know, and why files are important? And it's a low pressure one. So you know me, I'm gonna play videos that I think are funny. I don't care if you all don't think they're funny.
Did you find the files?
I don't even know what they look. What do they look like?
They're in the computer.
They're in the computer?
Yeah, they're definitely in there. I just don't know how he labeled them.
I got it. In the computer. It's so simple.
Zoolander, underrated movie. Good quote for files that will come up again. So what's today's agenda? We are going to look at how to open up files. Then we're going to look how to read files, how to write files, and then we're going to look at two very common file types, text and CSV. Right? So let's see how this darn thing worked out. What file types does everybody know? And so this is like a word cloud thing. So the things that are presumably bigger is what most people say. So a lot of people said the word files. I don't know, I guess. But yeah, PDF, text, PI, JPEG, MP3, MP4. Yep, those are all file types. Why is it important in programming? Some of the keywords that were selected here. Different. Yeah, that makes sense. Different files have different things in them. Word files again. Location, that's interesting. Ability, yeah, maybe different files have different capabilities. Some have code. Efficient, yeah, those are all good sort of keywords. So we'll get to that bit in a minute. But generally, I think I saw a lot of these represented. These are pretty common file types, just in general. We have files that hold documents, doc, PDF, text, RTF, rich text format, video files, executables, image files, audio files, compressed files, right? Zip, that's kind of like that run length encoder stuff we were doing. That's what those file types would be. You as developers, you have a special relationship with files that most of the general public won't. And so that is typically correlated with the language that you're using. So Pythons will be .py files, JavaScript will be .js, Java will be .java, right? You can put Python code in a file called .c. There's no problem with that. You could put R code in a file called .js. There's no problem with that. What will happen is your computer might get confused, and we'll look at that in a minute. Friends who may want to go into cybersecurity. I'm going to use this sort of interchangeably, but system administration. A lot of system administrators, part of their day job is being cybersecurity. And I've highlighted here some very specific files that are very important, particularly on Linux systems. I'm trying to put together project one. I should have that next week, where we're going to work with Etsy Password and something called Etsy Shadow. And so those who are not into cybersecurity, not a big deal. It's just going to get you comfortable with working with files. But those who are interested in cybersecurity, is going to teach you a little bit about how authentication works on Linux systems. The word of the day, AI file types. So AI is its own world. But generally, I'm going to give you like two big classifications. There's model files. So like at the end of the day, an AI model, that's the thing that's giving you predictions, giving you answers when you ask it questions. It's really just a program. That's all it is. It's not magic. But very, very important for AI is data files. You've got to train a model, right? At a fundamental level, all an AI model is, it's just a statistical answer, a probabilistic answer. You ask it, what's its favorite color? It will give you an answer. You ask it, what color is this desk? It will say gray. It's never seen this desk, but what it does is it's probably ingested a lot of images of desks around the world and made a guess. So why are file types important, right? I think we've all learned there's a limit to how much you as a human can digest when you're looking at code, right? We haven't even been looking at big programs yet, but already we've introduced you to modules, right? I put other data in other files. When we had those song exercises, right? I created like that catalog thing. Well, imagine how hard your code would have been to read if you had like 50 lines of just random songs and then like 3 lines of your code. Screw it. I put that stuff in a separate file, right? Also, what do you do with really, really large data sets? So some folks have asked about like big data. What are you going to do? Are you going to put a terabyte of data in a file and then again 20 lines of code? Like, it doesn't make any sense. The last one, exchange data with other programs or systems. This is actually quite interesting to me. Files on a file system are used not just the way you might think of like a piece of paper or something. Files are used for a lot of things like socket connections. So what do I mean by socket connections? Think about like a socket on the wall, right? We don't have wires into our computers anymore, really, but you used to always have to put a cable in your computer to put a cable into the wall, right? And it's effectively a socket. It's a physical socket. Your computer, when data is coming from the internet into your computer, it's actually writing it into a file. And then your web browser is reading that file. Now, in the case of things like streaming video and streaming audio, it's reading it very, very fast. But it's using it a lot of times for a purpose called buffering. Have you ever heard of the term buffer? Like you watch a video, it stops, and you watch a video, it stops, and then it catches up. Well, fundamentally, what's happening is that data is coming across the wire into your computer, and it's filling up a file. And then whatever you're watching your video on is reading from that file. And if there's nothing in that file, it's just waiting for that slow Aggie Pride internet connect to give you another byte of data. So files are fascinating. When we look on our computer, right, hopefully we've all seen maybe this sort of structure. I do find it fascinating because I think at some point in time, this whole metaphor kind of goes away. So again, don't want to age myself too much, but when you grew up before computers, everything was literally in manila folders, in files. Like you still see it a lot of times when you go to the doctor's office, right? You ever go to a doctor's office and you see they have like these big tracks of like files, right? I mean, that still exists today, but that metaphor was incorporated into computers because that's just what people knew. Said, okay, well, I want to have all my, I guess, 3D objects in this folder, right? Or here are my documents. I want to have all my documents in this folder, right? I want all my music over here. There's not a lot of files on here, but if I could find some files on this, what your computer is fundamentally trying to do is say, okay, listen, I see a file type .doc. I'm going to make your life easier, human. When you click on a .doc file, I'm going to open up Word. When you click on an MP3 file, I'm going to open up an MP3 player. Again, back to my friends who are into cybersecurity. Don't be a sucker. Just because it says .zip file doesn't mean it's a zip file. Just because it says a .doc file doesn't mean it's a doc file, right? There are so many attacks that occur because somebody would email someone something that says .pdf or says .zip file. And then you as the human, you go in and you click it and it opens up Word or it opens up your zip program, right? Well, what's happening is the attacker knows there's a flaw in your zip program. There is a flaw in Microsoft Office, right? And so what it does is, it's actually not a Microsoft Word document. It's not actually a zip file. It's code that when it opens up the program Microsoft Word, it exploits that, right? And then now now it has control of Microsoft Word. If you're on a Windows machine, Microsoft Word is highly coupled to Windows. Ooh, it knows it has elevated access into Windows operating system. Now it can get control of your hard drive. Now it can just start reading all your files, right? Take off your images, take all your whatever private data. So long story, but files are critically important. And I think this is, again, where the course gets kind of super interesting, because now you're going to write programs that can start interacting with the outside world. And the first place we're going to interact with is files, right? If I get some time, maybe we'll do network interaction, finger crossed, because that gets even more interesting. Okay. Okay. Opening and closing files. So back to the core stuff. How do I open a file? This should come as no surprise at this point in the course. There's a function for that. That function is called open. Open takes two parameters. The first one being the name of the file. There is usually an assumption that your program, you started it somewhere, right? If I'm on my Windows machine, I have a start menu. I can find where that program lives on my machine. So there's typically assumptions that the program knows where it's running, and that's where it's going to look for files. But it's not limited to that. If, and again, we sort of showed that, there's a directory structure, there's a hierarchy on your computer. There's the C drive, and there's the users folder, and then there's every user who has an account on that machine, and then there's your downloads folder, and then there's your 3D object folder, whatever. You as the human should put this full path in and say, open a file way over there. The second parameter, which is there to, dare I say, keep us safe, is the mode parameter. Okay. I guess maybe the last subtle point. Open is just a function that returns a variable, which is a reference to that file. And we'll show you how you can read from a file using that handle. So these file modes, there's really three that we're concerned with: R, W, and A. Read simply means I can read the file. I can't edit it. Write means I'm going to overwrite that file if it exists. So any content that is there, I'm going to nuke it. Append is I'm going to take the contents that are there and just add to the end of it, right? Why do we think having these three modes would be important? File manipulation. File manipulation. And so in some cases, you might want to manipulate a file. In some cases, you might not. Okay. Restricting someone else's ability. Cool. So like to touch on those two examples, right? Let's say, your phone's a computer. You take a picture on your phone, right? Presumably, the thing you're using to view the picture, well, you don't want it to edit your picture, right? You might have an editing program, editing software. You want that editing software to edit that picture. If you were going to email your picture or just SMS it to somebody else, I personally wouldn't want my SMS picture to have or SMS program to have the ability to manipulate my picture, right? What if the SMS software was compromised, right? And somebody now like jacks up my pictures or whatever? That wouldn't be cool. There are additional modes, which in reality is what you use most of the time. You use this R+, W+, and A+. Most times you don't just want to write to a file. You want to write to the file and then read it, right? Or you want to append to a file and read it. A lot of times you might do that for error correction. You as a human might want to know, hey, what I told the program to write, did it really, really write it? So we have these R+ modes. which all fundamentally do the same thing. I have some details there, but yeah, this is what we generally will use. If we can open a file, we should be able to close the file. And I want to recast what I just said. It's not that we should be able to close the file, it's that we want to close the file. I'm trying to give the image in this imagery that it is really, really, really bad if you have a whole bunch of files that are open. And the reason is well, I don't want to be too negativistic, but people make mistakes. Let me put it that way. So if you have a program that's supposed to be processing, let's say it's like a doctor's office program, it's supposed to be, you know, reviewing or doing something with patient files. You really don't want that program to have hundreds or thousands of patient files opened up in memory at the same time, because maybe the programmer made a mistake, and maybe the programmer is like, oh, I need to update the date of birth on this record, and they grab the wrong record instead, right? So it's very, very important that we close our files. It's so important, in fact, what I'm showing you here, we are probably going to do once, maybe twice, just so you understand the fundamentals, and then we're never going to do it again. We're going to use something called the context manager. And the context manager really has one purpose, and that's to make sure that a file gets closed. It's critically important that a file gets closed because in most operating systems, not all, but in most, only a single program can edit a file at a given time. So if you had like, I don't know how many times you've done this, but you know, maybe you have like 2 instances of Microsoft Word up, right? You can edit the same file. But years ago, there wasn't concurrency. And so like if you started typing in something, you had this window up with Microsoft Word, you start typing, and then this one you start typing, you might have overwritten your changes, right? And so it was critically important that only when this file or this program was in the process of writing, then it said, okay, cool, I'm done writing. I'm going to close the file. I'm going to now open it for reading. And then the other one has the ability to open it again. It's really important when you have 2 different programs operating on the same file for very legitimate reasons, right? You might have, like I gave the example, one program that's reading the data from your internet connection and dropping it into the file, and then you have another one that's over here, your web browser, that's trying to read out of it. So there are cases where you want to have multiple programs operating on the same file. The syntax here, and again, I'm really hoping at this point we've seen this pattern. You're going to start to get this Pythonic sort of method. It is a little weird. You have to think a little bit differently, but with open as F. And it sounds kind of insane, but what that does is it does the same thing as that. So there's F equals open. This says with open, so it gets that file. There's no real variable assigned to it. It does the assignment that way. Then you indent and you do whatever you want to do. So this is here, and I will agree, it's kind of a nice feature of Python in that it makes it very clear to you as the programmer, you as the person reading it, this file needs to be open for these 2, 3, 4, 5, 6,000 lines, whatever it is. It needs to be open here for me to do my job. But it also makes you aware, wait a minute, I shouldn't be writing a 2,000 line program and have my file open the whole time. That doesn't pass the smell test. I mean, I kind of went through this. There are a lot of different reasons, but primarily, you as the programmer don't have to remember to write close. It will do it for you automatically. We will get to exceptions later. Some people have experience with that. There might be a problem with taking your data in writing it. What do I mean by that? I mean literally the hardware. Like, hardware breaks. Stuff in the real world is not impervious to problems. And so you might have your program that says, I need you to write this information to the disk. This disk could fail. It's a piece of hardware. Stuff fails. Even if it was a solid state drive and not a physical hard drive like this, it still fails. And so you don't want your program, which may be a very critical program, to fail because it couldn't write to the disk, right? You might go and work in embedded systems. You might be working on the next MRI machine. I sure as hell do not want my MRI machine that I'm in the middle of getting a scan, right, saying, I couldn't write the data to the file. I'm going to continue to scan Dan's body, right? And then it screws up in some catastrophic way. So this stuff is super important for real reasons. All right, typically here is where I go into EdStem, but opening and closing a file doesn't really show us much. So we have to learn how to read a file. So I'm going to use this example kind of over and over for a little while. Let's assume we have a file that looks like this. You can open up a file on your computer, and it just got a bunch of lines, which I'm going to say are issue logs. So, you call up Amazon, there's somebody on the other line, say my package wasn't delivered or whatever. They say, okay, this is issue 1, it's in progress, I'm troubleshooting it. Or there's so many people on the phone that are saying, okay, issue 1 in the system, issue 2 in the system, issue 3 in the system, and then somebody else is going to go triage them later. How would I read that file? There's 3 key ways. There is a method or a function called read, one called read line, and one called read lines. So we'll get into EdStem and we can do the code along, but read, if I have a file that has these 8 lines, I use my context manager to say with open project underscore issues.text for reading as F. Issues equals f.read. I could put f.read right inside print, it doesn't matter. That's going to print everything in the file immediately. That's sort of useful. I would argue it's not very useful. What if your file had 10 million lines in it? That's not useful. This is where we have something called read line. So if I have a file, if I have my file handle f, if I say f.readline, unfortunately, there's an equal sign here. If I say print issue, that is going to identify the first line in the file and print it out. Notice, there's an assumption that there's that /n character. So we talked a little bit about that. And probably for a while, you're all like, why is that /n important? It is critically important in file systems. Files need to know where the end of a line is. It's touched on briefly in Zybooks, and we'll talk a little bit about it. Windows, in their wisdom, or Microsoft, they kind of like to screw everything up. It's not just /n, it's /r/n. There's 2 characters. It's hell. It makes your life hell as a programmer. Fortunately, in Python takes care of it for you. And it detects which operating system you're on. And maybe you read in Zybooks, if you got to that part of the chapter, there's like, and you need to do this crazy thing with sys dot blah, blah, blah. Like I read that stuff in Zybooks and I was like, this is just insanity. And I blame Microsoft. But back to the point, when I do read line again, and then I print, it prints out the second line in that file with that empty new line. So we have to be careful with that. Finally, the third function, read lines. When I read lines, this is actually super useful. This gives me back something inside square brackets. What is something inside square brackets? A list. If I see a list, what might I want to do with a list? What's that? Iterate. Exactly. Right? Typically, when I want to process my file, I want to do it like line by line. All right. Assignment 8. Same deal as always. If you want to code along, or you can view the submissions or the solutions afterwards. Right. Open the file for reading. Read using read and then close the file. So very simple. The way we're only going to do it once or twice and never do it again. F equals open. I'm going to use this variable file name. For reading, case is important. And then I'm just going to say print f.read. Again, I want to close my file. Very easy to forget to do that. Okay, so here's this file, project_issues.txt. You can see the content in it. Here's my program. I run this up, and there's 1, 2, 3, 4, 5, 6. Okay, what do we have up next? Yeah.
So if you don't close it, like you don't put close at the end, would that give you an error, or would that it would just say open?
Yeah, that's the thing. It's kind of equivalent to like a semantic error. Your computer is just like, fine, you want the file open? Fine. Like you might need it later. It doesn't really know when you may want to close it. So it's not going to make that decision for you. Yeah. Okay. Open the file for reading using just read lines, then close the file. Take, again, lazy. Open for reading, and then just do read lines. Right? Gave me a list. Right? Now, because it's a list, I can do something like 1 to get the, not the first element, but the second element. That was my second element, right? And I have to use my mouse here to show you, but remember, that's that new line there. So kind of stinks, but it is what it is. And you can actually see it, right? Like when you look at this, you see /n. This is like a real pain in the ass as a developer. You kind of have to remember that. Otherwise, you might be, why do I have new lines all over my program? Okay, part 3. Open the file for reading. Loop over the file itself. So this is something I sort of just skimmed over, but the most efficient way to read a file, that's what we're going to look at now. Okay, so let me take the code I already had. I have my file. Now, a file is iterable. So I can say for line in F. And then here, I can just say print line. That prints all my lines. Now, again, it has that gnarly /n in it, but that's not a lot of code. That's pretty succinct. That's pretty elegant, right? That's most of the time how you're going to write a file. You just have, or read a file, pardon me. You just have to remember about that /n. Okay, read from a file, read line, and then close the file. Okay. Open the file, use read line, then close the file. Okay, so here, trying to think what my instructions were. My gut tells me I'm going to use a loop. Why am I going to use a loop? I have no clue how many lines are in this file. So I'm going to say line equals f.readline. And then here, I'm going to say while line while I have a line, something that's talked about in Zybooks, there's this concept of a end of file character. So the end of file character sort of acts like a Boolean value. It'll be like true or false. So here, I can do this. Right? I read all of my line. Now I had to be careful there because number one, I read this outside of my loop, but then I had to remember to print out that last one. Yes, Sam? A file that has a bunch of what in it? Yeah, good question. So typically a picture is in its own file. You very rarely would have like multiple pictures in the same file. There's a whole section in Zybooks, which we're going to cover on Wednesday, on binary files. So pretty much any program you use, the data is going to be stored not in plain text. Yeah. But this sort of stuff, again, cybersecurity, system administration, all your stuff is in text files. Yeah. Yeah. No, the file is going to define it like based on what the operating system wants it to be. And this is, again, why I think files are really cool. The files are at the physical hardware level, and your operating system needs to know how to deal with that. And it's like, no, Python, Java, you don't get to make the decision. I am Windows, I am Linux, I am Mac. I am going to determine how to deal with the hardware. And then they tell Python and Linux and Mac, you want to read a file? My lines are going to be /n/r. You want to read, you want to know what the end of the file is? It's going to be something else. There's other hidden information as well, which we don't really get into. They're called byte order markers. Most files will say whether they're big endian or little endian. And so something really cool that Zybooks does, it's giving you hints about stuff you're going to learn in more advanced courses. So do you remember we wrote that program where we did the reverse binary thing? If you were to read a file, the same file on Windows versus Mac or versus Linux, it's going to look different. Even though it's the same file, one of them is going to read from the front to the back, and one's going to read from the back to the front. Good question. Okay. Moving on down the line. Part 5, the context manager. So very simply, and again, this is what we get used to this. This is what we're going to use all the time, right? In this particular case, we're going to say with open, whatever the name of my file is, whatever the mode I want to read my file in, as, and I can give it whatever name I want. File's a reserved word, so probably better to use F. Boop. Then I have to indent. Remember, I have to indent, right? And so then here I can say, you know, f.read, whatever I want. Okay. And again, leave it to you as an exercise. There's other parameters here. How many bytes you want to read? So here I want to read 10. Here I want to read 100, right? Sort of useful, not overly useful. Okay, good. Your turn. So this is one of those things, and maybe I'm getting just a little disillusioned and discouraged a bit. My intent with these freebie exercises is that y'all actually code along. And I get it, if you learn better just observing in class, but you have the material that comes from Zybooks, you have the material that comes from lab. I'm trying to give you the material you need here for the assignments, right? So I'm going to leave this last one your turn. Up to you if you want to do it. It will likely help you when you go on to the graded portion of this assignment, right? So in this particular case, you're going to read from this same file, right? And notice this file has a bunch of priorities. Some of them are marked high, some of them are marked low, some of them don't have a priority at all. This is asking you just to read from that file and just create a list with the ones that have the word hi in it. So again, everything you need to read a file, we just covered. All you need to do down here is to apply what you learned in the previous sections. So if you have to look, you have to iterate over each line. Everybody knows how to iterate. You have a line, which is just a string. We should all be familiar with the find function at this point. If you call find on this line and look for the word hi, if it returns you anything other than -1, the word hi is in that line. Okay. So I'll leave that as a takeaway. Okay, so if there's reading, surely there must be writing. Files don't just get created out of nowhere. So we have this write function. In this particular case, how does this journey start? Well, I do have a file, but my program has a string. So here is my string. My variable name is content, and I gave it issue 9. Using the context manager, I open up my file. It shouldn't be a big surprise. I just say write. Only real difference from the last part of the problem is I have W instead of R. Please be aware, you're going to make this mistake. I make this mistake. Everybody makes this mistake. This is my file. Who wants to predict what's going to happen when I say write? What's that?
Write the content.
Yeah, what's the file going to look like at the end of this?
I'm gonna add that last line.
Good, that's the mistake I wanted you to make. Write nukes it. When you have something in write mode, it nukes whatever you had there. So if your file has all that groovy information,
It's just gonna write.
if you do write, it's gonna nuke it.
And just gonna write down.
Write it over, overwrite it. What you want, what you usually want, is append. So here I have my string. The only difference here, I'm opening the file in append mode.
That's what A is.
Yeah.
Okay.
And now I'm going to write my thing. There it is. It shows up.
How many different modes are there? Is there like
R,
yeah,
W,
R, W.
A. And then R plus, W plus, A plus. All right. Time for Mr. Ed. Write to a file. Look at pretty.temp, or sorry, temp.x. So here's a file that has the lines 1, 2, 3, and 4. Prompt the user for a message until the message is blank. Every time the user gives us a message, write it to the file. Okay, so let's look at the code. Using the context manager with temp.text, open it for writing. Right. I wanted to save myself some time here because this isn't new in this lecture. So I have a variable called message with the value none. While message does not equal the empty string, well, the first time through the loop, it says the value none, so I know I'm going to enter the loop. Prompt the user for a message. As long as they don't immediately hit the enter key, write that message to the file. And notice I put my separator on there. Now I know I'm working on a Linux system here, and I know I should do /n. Pay attention in Zybooks. They will tell you what you need to do if it's on a Windows machine. Now, in this class, if you're working on a Windows machine and you're using EdStem, this actually isn't happening on your computer. There is a virtual machine that's running in some cloud somewhere. That's Linux. But if you were using the command line on your machine, if you were using PyCharm, you would have to use somewhere, there's some like sys. I don't know, new line or something. I'll find it. It's in the Zybooks material. So here, hi, there, Monday. And then I'll just hit enter. So now my file has hi, there, Monday. Remember, I opened it in write mode. So it nuked what was originally there, which was 1, 2, 3. Finally, let's look at append. Well, there's not much to look at here, man. It is the same as the last program, except I put the letter A there.
That used to be it.
Oh, and so actually, let's just take a quick peek. Temp.text starts out with the values 1, 2, 3, 4. So when I have C, U, Wednesday, new line. Now when I look at my file, 1, 2, 3, 4, C, U, Wednesday. So that's all it is to writing files. Pretty easy. Okay. What's that?
I remember these guys.
Yeah. CSVs rule the world, whether you know it or not. So CSVs, comma separated values, generally look like this, and you see this all the time in pretty much any computer system. It's human readable, it's in English, but it's meant to be a grid, right? What has made this so super powerful is Excel, spreadsheets, Google Sheets, whatever you want to call it. It kills me. Like, I thought I would see spreadsheets die by the time I got to this point in my career. Every single business relies so extensively on spreadsheet. It's almost disgusting to me as a programmer because there's so much better things we can do. But you will find any industry you go in, everybody is using spreadsheets, and they're organizing data fundamentally as CSV files. Now, in some cases they're tabs, but you will always see I can export it as a CSV. It's so important, in fact, there's a whole separate module, import CSV. So the CSV module has a whole bunch of functions in it, but the ones we really care about, read and write. If you want to explore the others, be my guest. How do we do that? We learned that with docstring. Help, open parentheses, CSV. It will tell you everything you need to know. Inside CSV, there is a function, which is the reader. Now, I still need to open a file. So I should use the context manager to open my file. But instead of saying f.read, I use my reader, csv.reader, and I pass in my file. Then, just like with the file notation, it's iterable. I can iterate over it. And it's going to give me, from this file, every time I go through this loop, it's going to give me a list. It's not giving, so a file, every time you went through a loop, it gave you a string. Here, it's giving you a list where it said, okay, fine, this is the first thing, this is the second thing, this is the third thing, right? It makes it very easy for you as a programmer to process data. This is very common way that companies interchange information with each other. Again, I thought this stuff would be dead by now, but it's not. There's other formats called XML. There's formats called JSON that are very popular, but this is very, very commonly used. In a lot of cases, you as the human know what that data is, and so you don't care about that first row, which is the header. You just care about the data itself. I don't know why Zybooks doesn't tell y'all about this function. I think this is critically important, so I'm telling y'all about this. There is a function called next. If you pass what your CSV reader gives you, it will skip whatever row it's on. So in this particular case, I skipped the first row that printed out everything else in my file. Finally, there's the writer. So just like we have a reader, when I wrote a file, I wrote a string. When I write a CSV file, I write a list or a list of lists. If I want to insert just a single row into my CSV file, I use my context manager to open the file. I get a handle to this data writer thing, and then I say write row. I can foresee this already. People are going to put strings in here. You don't put a string in there. You put a list. If you already have a bunch of lists, you have a list of lists, you can just write them all in one shot. Okay? Yeah.
So like, how would you, so say for example, for items to order, say for example, you want to put it in the middle of like that first and second row, would you just put like?
Ah, good question. So you would actually have to rewrite that file.
Oh, so you can't actually insert it also. Okay.
No, a CSV file, that's a very good question. It depends on the mode you put your file in. In this case, I have it in mode W. It's just going to nuke the file and put it in. Append is just going to put it at the bottom. There's another function, which we're not going to get to today, called seek, where you start reading a file, and then you can say, go to seek line 7, seek line 12, whatever, and then you can do stuff.
Okay.
But you have to pull out what's there first, put your stuff in, and then like rewrite.
So you wouldn't be able to like split it up, put some in the middle.
No, but there's libraries for that. All right.
No way, compadre. We got 30 years worth of files right here in this computer that are gonna bring you down.
Oh no.
Turn down! Where'd all the files go?
Not that you're going to be bored this
No
week.
way,
if it's
compadre.
right, but, that's that. All right, gang, just a heads up. Monday, obviously, we're off. Wednesday, quiz on chapter 7, which is function. Thursday, assignment 7 will be due at 11 p.m. We will be working on files in lab. Friday, lab 8 will be due. Homework 8 will be due as well. So get going on 8. Have a good one.